are back with 7th and last video of our Robotics Picodegree. In our first 6 videos, we started with bringing up the system and teleoping the system with keyboard. Then we mapped our house and we did localization, after which we did navigation on the same house and also we did obstacle avoidance. So now our robot is ready for any application as our navigation stack is mature. So in today's video, we will look at a particular application where our robot will be used for a scenario where it will autonomously navigate in a disastrous situation like fire or flood. It will go in the house and look for all the humans. It will capture the images of humans and it will come back and report all the images to the 911 people. So this robot will help in reducing the casualties and giving better information to our first correspondent 911 people. So this is a classic example where we will use object detection, that is, we will detect humans. Before getting into details, let's see applications of object detection. So first of all, the best application you can see is self-driving cars. Also, in warehouse automation, object detection plays a vital role. If you want to know that your machine needs maintenance or not, that decision can be taken by object detection. Also, we can do face recognition and authentication by object detection. Object detection can be helpful where you can pass robot in a hazardous situation which will increase human safety and will reduce mundane work of humans. Also, this image recognition can be used by web services and you can get better and robust results. And finally, let's talk about what all are the assumptions of our project. So first assumption is we are assuming that we have map of the casualty house, because if we don't have map, project will have SLAM included and you will have to navigate depending on unexplored spaces. Also, in this project, we know the coordinates of all the rooms, so we are giving goals in different rooms, which is making human detection easy. Also, we are assuming that our robot has perfect GPS location. If we don't have that, we will have to integrate different sensor fusion methods and get multiple sensors to predict the location. And also, if there is a calamity, there is a chance that fire or water will hose up our electronics. So we are assuming that our robot is safe of those calamities. And last but not the least, the image from camera which we get is not affected by the environment, because in real scenario, if there is fire, your image will have lot of intensity changes and it will be difficult for doing human detection. So these are some basics about the project. Now let's learn about an object recognition technique named YOLO, which is super fun and which is being used a lot because of its blazing fast speed. So we'll learn first about YOLO and then we'll see the exact implementation in our project. So now let's go to our repository. Those of you who are following this Picodegree, you must be having a workspace named Webots workspace, and in its source folder you will have a folder named Robotics Picodegree. And if you are new and you have directly landed to this video, you can clone the Robotics Picodegree repo, which is in Soft Illusion on GitHub. The link will be given in the description. And now, once you clone it, we'll go to Robotics Picodegree folder. And if you are following the videos, you will be in some other branch. So for sanity check, you can do git pull origin main, and all the changes will be pulled in your repo, and do git check out main. And also for today's video, we will be using YOLO. So YOLO has a ROS implementation named darknet ROS. So link of this repo will also be given in the description. So you can go through the documentation of how YOLO is implemented, and also we will talk about it in a bit. We have instructions of cloning the repository, and we catkin made the repository. Once we do that, we will have two different repositories and we are good to go. So before seeing the implementation, let's understand what is YOLO, and I will also be sharing a great YOLO resource in the description. So let's start with full form of YOLO. So it's you only look once. And those of you who are computer vision specialist, it is a single stage detector. So basically localization and classification is done with the same convolution neural network. And it is unlike RCNN, which are two-stage detector, where localization and classification is done by different networks. So now, first of all, let's go through terminologies in object detection. So you will find this very often where there are some algorithms which just do the classification part, which will tell you that there is a cat or not cat in the video. Then if you do a bit fancy, you can do segmentation, where you see here the grass, cat, tree and sky, all these are segmented differently. So that is known as semantic segmentation. After which there is also a way where it will tell you that there is a cat and also show you exactly where the cat is in the image. This is a bit advanced, where there is classification and localization of the image. And same analogy goes for multi-objects, where you can do object detection and localization of multiple objects, and also you can do segmentation based on which classes you find. So YOLO is capable of doing object detection of multiple objects, which is what we need in our project. So if you go through YOLO paper, I find this fascinating, where YOLO is also known as dark 53 because it has 53 convolutional neural networks. So you see image size starts from 256 by 256 and slowly reduce, because at the end we only care about if the object is present in the boxes. So this is a pictorial representation of how the image size is decreasing, but its width is increasing. And finally, this is our output. So now we will exactly see how YOLO spits out the output, because that is the most important part for us. Now let's talk about output of YOLO network. So we take any image and divide it into S by S grid. So for this particular image, we have a grid of 7 by 7. So now we don't care about each individual pixel, but we only care about these 49 boxes. So that is why in our output of YOLO, we have S into S, which is 49 boxes, and each box will give this output. So now let's discuss about this particular 3. So this 3 is maximum object per box. If you have more than 3 objects centers in a particular box, then only 3 of those information will be captured. Practically, it is more than enough. This is the information of each object. So now, if we have an object, for example, this will be the box where the object dog will be recognized. So if dog is recognized in this particular object, we will have 4 placeholders for width and height of dog and center of dog in this particular cell, so that dog can be reconstructed again when we mark our image. After which we have a placeholder for if any object is present or absent. So for example, if we take this cell, there is no object of any of these 20 classes present. So this will give this placeholder as 0, and after which these 20 don't matter because this shows that there is no object in that particular box. And if this value is 1, then we need to specify the probabilities of each class. So for example, in this cell we will have probability of dog as 1 and probability of all other things as 0. And there is a bit of confusion where even if this cell has dog, still it will have probability of dog as 0 because center of dog does not lie in this box. Also maybe cycle, this cell will be having the center of cycle, so all other classes in this cell will be 0 and cycle will be 1. So now let's discuss about what all changes do we need to do in our package in order to integrate awesome functionality of YOLO. So if we see, this diagram will be a bit familiar to you because in our last 6 videos we have developed our Bringup package and our navigation package, and we have integrated it with Webots. So in today's video, we will have to add a package which will continuously give different goals to our navigation package, and also we will need to see how we added the YOLO pipeline. Now, if we go a bit deeper, we will see that what all things we need to update in our repo. So first of all, we found a simple navigation goal package where if you define XY thetas in launch file, robot will continuously go in different rooms. So this particular package is providing us with set of move based goals in different rooms. So that is why in the glance of implementation, you saw that robot was going in different rooms and capturing images and finding for humans. This package only cares about giving the goals to our move base and receiving the results. On the other hand, we have image stream from our Webots. So we take the image stream and we know that image comes as slash robot name slash cam slash image, and we will convert this topic name to slash camera RGB slash image underscore raw. So once we do this, the stream of data will be remapped to this particular topic, which is expected by darknet ROS. So this package, we directly cloned it and it works as charm. It will take in the output from Webots, which is camera slash RGB slash image raw, and it will give an output of bounding boxes. So if it detects multiple things, it will give you that which classes were detected and what are the bounding boxes. We add a processing node where if human is detected and if probability of human is greater than 50%, we save the current image in a particular folder. That is how this information can be used by our first respondents people and get to know that how many humans are there in a calamity situation like fire. So you will see in our package, if you run our launch file, there is a folder where you will see different humans and different views of a particular human being saved as images. Now let's look at implementation of the project. So first of all, in my Robotics Picodegree repo, I have a Bringup package and images. Here I have lot of human images which are captured from my last run. So let me select all and delete those images for now, because now when we see the implementation, the new images will be populated whenever human is detected. So let's go to terminal. Let's source for sanity check. Let's do catkin make so that we are sure that everything is built. Now let's do source again and ROS launch, bring up master.launch. So in our main repo, everything is configured in this launch file. Once you type it, it will show up RViz. It will show you the Webots, and it will also show the output from YOLO. So you can see here. Okay. So first of all, let's look at goals. As we saw in the theory, we have a package which is responsible for giving different goals to the system, where if you see here, robot got a goal. It just detected a person. So robot got a goal to go to this bathroom, then it will get a goal to go to bedroom, then there is a goal for kitchen, then it will go to dining, living room, and finally back to lobby. So in this project, we have fixed the locations of where to go. But if you have a project where you don't have the map and you are implementing SLAM, it will go based on where the region is unexplored. So it came to the place. Now let's have a look at where all do we have humans in the system. So I'll minimize this. For our scenario, we have one human in bathroom, one human is sleeping on bed, one human is in kitchen, and one is in terrace. So you see the robot went to kitchen, now it will go to dining, living, and finally back to the lobby. So this is all the placement of human. If you feel like changing something and trying new things, you can shift the humans wherever you want. You can shift this human to this corner. You can make this human straight. You can change the dress of human. And you must be noting one thing, where our human is kept below the ground. This is just for this particular application purpose because our robot is very small with respect to human. So in real life, our robots will be able to see complete human and it will work fine. Now let's look at our detection topic. So if I do ROS topic echo on dark ROS bounding boxes. Oops. I need to source. If I do this, Currently it is not publishing anything because nothing is detected. Once it detects human or any other object, see, we can see here that it detected person with a probability of 0.6, and it also gave the coordinates which is bounding box of a person. Similarly, it can detect multiple classes. So it detected person and chair here. This is the information which we used for our application, where if our probability is more than 0.5 and if we detect a person class, then we save that image. Frame rate is 1.2 frames per second, but if I enable GPU, or if your machines are having good GPUs, it will run pretty fast. If you have information about Docker, do run the same project in Docker. It runs at a blazing fast speed of like 150 frames per second. Now let's dive a bit deep on what all our model can detect. So for today's application, we are using YOLO version 2 Tiny, and in this we have around 70 things which can be detected, and here you can change the threshold. So if the value which neural network predicts is more than 0.5, that means 50%. That is only when it will show it as detected. And this file is found in configuration of darknet_ROS package. So if you go in configuration, you have YAML2-tiny, and also you have ROS YAML where you can change the publisher and subscriber topic names. So this is all about project. I would be really happy if you try the project, change the scenario, change people, and see how it is implemented. And finally, let's go back to our images folder. This is where we deleted everything, and now you can see you have pictures with different humans. So it detected this first one, second one, third one. It also detects half human. So these, and the fourth one. So it detected all 4 humans. So this was a small application with YOLO. If you have any questions about YOLO, or if you have any questions about this particular project, do comment. Also, you can go through the README, which is very descriptive, and all the steps and all the commands are written in the README.
Hope you like this Robotics Software Picodegree. This series would have helped you get a great understanding of mobile robots.
If you haven't watched this series completely yet, or you are new to mobile robot concepts like mapping, localization, navigation, obstacle avoidance, ROS, or Webots, we recommend you to get your hands dirty and implement this project.
It was a great experience creating this content. We received great response and several people had many questions.
So you know what? We are coming up with live sessions, so do subscribe so that you get notified. Also, we are coming up with many concept videos, so stay tuned.
Do comment if you need videos on any specific topic or your feedback on the current videos.
Stay hungry, stay foolish. Bye bye.